Hey YouTubers, it's Eli the OBD Tech. I'm still here working on this 89 Nissan pickup truck. The problem with the fuel pressure regulator, it hasn't been fixed. The component had to get pressure ordered through online. I think it's coming all the way from New York, so it's going to take about a week. But the customer did call me up once again because he forgot to mention if I could check for him the operation of the windshield washer system. He said that the washer motor seems to be working, but there's no fluid coming out of the washer nozzles. Perhaps, there's some type of, perhaps a restriction or maybe low fluid on the reservoir. I'm not sure. He also mentioned that the horn wasn't working. And last but not least, he said that the low beams were not working as well. He said that the high beams work, but not the low beams. So I guess the first thing to this diagnosis or troubleshooting video is I'm gonna go ahead and do the windshield washer operation first. Since the customer did confirm that the switch was working along with the washer motor, so I'm gonna confirm with you guys real quick. So I'm gonna hit the wiper switch to see if it's sending power to the washer motor. So here we go. And this operation should be done with the ignition switch either in the ACC or in the on position. So I'm going to put it in the ACC position. I'm going to hit the switch. I'm going to push it forward. So here we go. So as I hit the switch, we do hear that the motor is working. But the problem that there is no fluid coming out of the washer nozzles. So I guess the next step to this troubleshooting is to go out there and perhaps do a visual inspection on the reservoir to see if we're probably low on fluid. Alright, so I'm going to show you guys real quick. Okay, so I'm here where the washer reservoir lives. Just by the glance of it, by doing a visual inspection from the outside of the tank, it seems that there is some type of fluid in there. It's low. But best things to do is to do a visual inspection inside the reservoir. So by the looks of it, it does look bone dry. There's actually no fluid inside the tank. So I'm thinking, guys, that perhaps the customer was fooled, thinking that the reservoir did have some type of fluid, because it is deceiving. Just for the fact that there's actually a blue stain inside the reservoir tank that makes it look like there's actually fluid inside. So that's what probably the customer thought, that it did have fluid. Maybe he was lazy and he didn't check the inside of the tank. So as we see inside the tank, once again, the reservoir is bone dry. So I guess the next step is to actually add some fluid to see if the washer motor is able to send fluid through the hoses all the way to the washer nozzles. Alright, so I'm going to go ahead and put some fluid and then show you guys the operation once again. Alright guys, so I added enough water up to the point where the washer motor lives, at least to the point where it's going to be able to suck some water. Let's see if the camera could pick it up. Perhaps not, but it's to the point where the hole of the washer motor lives. So I'm gonna, so I'm gonna go ahead and hit the wiper switch once again. And see if this operation works. So here we go. I'm gonna hit the switch once again. I'm gonna put in the ACC position. I'm gonna hit the switch. So here we go. So we do see that the nozzles are spraying water. So the problem here was just low on fluid. So this is one problem fixed already. So the next thing I'm gonna troubleshoot is the horn for you guys. Alright guys. So I'm gonna check the operation of the horn switch. So when I press the horn switch, we should hear the horn honk. At the same time, we should hear the relay click. So I'm going to verify if the switch is working properly by pressing on the switch horn. And if the contacts on the switch are closing That means it's going to send the 12 volts to the relay, and the relay should energize and close the switch on the relay to send the power to the horn. So here we go. So so I'm pretty much checking from the operation from point A to point B, which is the relay. So here we go. So as I press the switch horn, we do see or hear that the relay is clicking. So, so I'm going to go ahead and do it again. Hopefully the camera can pick it up. So the relay is switching, so that means that the contacts on the switch are good. It's sending that 12 volts to the relay to energize it, to close the contacts on the relay to send the 12 volts to the horn. So I'm going to show you guys the location of the relay real quick, and then I'm going to use a test light to pretty much troubleshoot the circuit here. Alright guys, so the location of the relay for the horn, it pretty much lives here. It's a gray relay. At the moment there's actually a black cover that's covering the relay, but the relay is gray. It's a 3-wire relay. Alright, so the next thing I'm going to show you guys, I'm going to show you guys the wiring diagram to see how this circuit operates. So here we go. Alright guys, so before I show you guys the wire diagram for the horn system, I want to confirm with you guys real quick again that the location and the color of the relay is gray, as indicated here. And it's actually bolted to the right side of the fender, which is next to that blue relay, which is part of the interlock relay. It's for the USA manual transmission model. Alright. So here, I'm showing you guys the wiring diagram for this horn system. It seems that there's 2 horns for this truck. I'm going to zoom in real quick. It's a left and right. It seems that they're connected by 1 wire each. They're pretty much the same color wire. They're actually spliced, which is the light green with white, as indicated here on both of them. And then the ground is going to be chassis ground for both horns. And then it goes up to a connector, which is connector 15M. It's a 3-wire, which goes to the horn relay. As I mentioned earlier, that it's a 3-wire relay. And then the light green with black, it actually goes down to the connector 241M, which is part of the horn switch, which is on the steering wheel. And the switch gets grounded through the chassis ground. I believe this is going to be maybe chassis ground 273M. I'm not 100% sure, but I think it's 273M. So that's how this light green with white gets fed through those 12 volts. You hit the switch, it runs, gets down, and then it travels through the light green with white. But the way this 2 wires get the power feed is through this light green wire, which is the main harness wire, which goes up to there's 2 ways that this system works, either with the VG, which is the 6-cylinder, or the Z, which is a 4-cylinder 2.4. This is a 2.4 liter engine, so we're going to follow the one that has a C, the Z I mean. It's going to go up. So follow the LG one, and it's going to connect to this fuse box, which is located on the driver's side fuse panel, which is going to be it's a 10 amp fuse, which goes to the battery. So this is pretty much a simple circuit. There's a horn relay, there's a horn switch, and pretty much a horns. So I guess to test this first, I'm gonna connect a test light to ground. I'm gonna first verify that we're getting I could do both 2 ways. Check the fuse, which is that 10 amp fuse, to see if it's getting power from the battery, and then go down to the horn relay, back probe the light green wire to see if there's actually 12 volts on that connector on the LG wire, and then finally back probe the wire which is the light green with black, to see if we're getting the 12-volt source when we hit the switch, the horn switch. And finally back probe the light green with white to see if we're getting that 12 volts when we hit the switch as well. Alright, so I'm going to set up, go ahead and use a test light to check first the fuse, which is a 10 amp fuse. And if we have good voltage source on that fuse, then I'm going to back probe the light green wire, which is the main harness wire. Alright, and then go from there. Alright guys, so I'm here at the fuse box. Although we have already verified earlier that our horn relay was clicking as I was pressing on the horn switch, I'm going to troubleshoot this step by step. I'm going to start at the fuse box and just verify with you guys that the 10 amp fuse is getting the 12 volts from the battery. So here we go. The 10 amp fuse is going to be this one here for the horn, as indicated here on the description. So we go 1515, there's 1515 open space, and it's followed by a stop lamp 10 amp fuse and the door lock horn. So it's going to be this one here. So I already have my test light connected to a solid ground. So I'm going to back probe the fuse right here real quick to see if we're getting actually the 12 volts. We are. I'm going to test the other side of fuse. So that's going to be another solid light right there. So 1, 2. I'm going to go ahead and press on the switch, horn switch, to see if there's any glitches. That's good. Alright guys, so the next step is to go ahead and back probe the light green wire on the horn relay. Alright guys, so I'm currently back probing the light green wire which goes to the horn relay. This is a 12 volt feed that comes from the 10 amp fuse. So I'm going to use a test light. It's already connected to battery negative. I'm going to go ahead and touch on that back probe pin. And this test light should turn on, and this is pretty much going to confirm that we're getting solid voltage from the 10 amp fuse. Alright, so that means that our horns have a solid battery voltage from the 10 amp fuse. So next step is to go ahead and back probe the light green with black. So I'm going to switch the test light to battery positive. So in other words, this relay is almost like a ground side switch relay. So pretty much if I keep the test light on the negative and I back probe that light green with black, we're going to manually energize the relay. So we're pretty much bypassing the horn switch. But like I said, the next step is to go ahead and back probe the light green with black, switch the test light to battery positive, and as we hit the switch, the horn switch, this test light should turn on. So so I'm gonna set up and show you guys real quick. Alright, so I'm gonna show you guys real quick. I have my test light still connected to negative battery post. I'm actually currently back probing the light green with black wire. So I'm gonna show you guys that if we touch the light green wire with our test light still connected to ground, we're gonna manually energize the solenoid. Not the solenoid, the horn relay. So here we go. So as I touch the back probe pin, we hear the relay clicking. So that's a good way to also check your operation of your relay. But you must know the circuit design. So in other words, this is like bypassing the horn switch. So I'm gonna go ahead and connect the test light to battery positive. I'm gonna back probe the light green with black. As I back probe it, there's no light. The way to test this is to actually hit the horn switch, and this test light should turn on. So I'm gonna set up real quick and then show you guys. Alright guys, so I'm gonna go ahead and press on the horn switch, and this test light with the horn switch press, this test light should turn on. So here we go. Alright, so as I was pressing the horn switch, we saw that our test light was going on and off. So that just shows that our horn relay is getting a good solid ground. there was no glitches. So I guess the final check is to go ahead and back probe the light green with white. So let me set up and show you guys. Alright guys, so I'm currently back probing the last wire, which is the light green with white. That's going to be a 12 volt feed. As we press the horn switch and we close the contacts, that's going to be the 12 volt feeds that actually run through to the horns, both left and right. So in order to set up the test light, you must go back to a negative to the negative post, which I already did. I'm back probing the red pin right now. It's currently off. So as soon as I hit the switch, the horn switch, this light should turn on, and that's pretty much verifying that from the horn relay, it's actually sending 12 volts down to the horns, both left and right. All right, so I'm gonna set up and show you guys real quick. All right, guys, so I'm gonna go ahead and hit the horn switch, and that test light should actually turn on. All right. Alright guys, so that's so that pretty much verifies that our connection from the horn our horn switch all the way to the horn relay, we have a good battery voltage and good ground. There's actually good control on the relay. It's actually working properly. So our problem might end up being from point B to point C, pretty much from the horn relay all the way to the connectors. Perhaps there might be perhaps a bad ground on the horns, maybe faulty horns that are not able to produce that honk anymore, or perhaps an open wire between the relay and the connectors of the horns. I'm not sure. So I guess the next step is to pretty much back probe the connectors that connect to the horns to see if it's actually getting the 12 volts. And I'll be using the test light still connected to battery negative. So let me set up and show you guys real quick. Alright guys, so as I was looking for the location of the horns for the left and right, I saw that the right side horn was actually missing. It actually lives in this area here. That's where it should be. It only has the left side horn. I have already removed the connector that connects to the horn. I actually carefully front probe the connector with the test light. Make sure to be careful because you don't want to spread the female pin. And I have the test light connected to battery negative. So pretty much with the horn switch open, the test light should be off. This is a light green with white wire. But as soon as we hit the horn switch to close the contacts, this test light should turn on. And if it does, that's pretty much going to verify that we do have a solid voltage coming to the horn all the way from the horn relay. So I'm going to set up the camera and then I'll show you guys as soon as I hit the horn switch. Alright, so the camera already set up. I'm going to hit the horn switch and this test light should turn on. Alright. As you saw there, the test light did turn on as I hit the horn switch. So that just verifies that the light green with white wire it's actually getting the 12 volts all the way to the connector of the horn. So that pretty much determines that the horn, it's either bad or we have a faulty ground, a chassis ground that's not grounding this 12 volts. So I guess the next step is to verify that if the chassis ground is a good ground for this horn. Alright, so I'm going to set up and show you guys. Okay, so I currently have my test light connected to battery positive. I'm going to go ahead and verify it to see if this horn is getting a good chassis ground. So by touching the bracket here, or where it bolts to the frame, as I touch the bracket here, or even the bolt, we see that there's no test light being turned on. I'm going to touch different positions. So that just verifies that potentially the problem is going to be a bad ground that's not grounding the 12 volts that's coming from the relay. So another test or another way to verify if we have a bad ground is to perhaps use a jumper wire connected to battery negative, and use the other end and connect it to the bracket here on the horn. So I'm going to go ahead and set up and then show you. So I'm using the jumper wire. I'm connected to battery positive all the way to the horn's bracket, which is going to be our ground, chassis ground. So by me doing this, this is going to verify if we have a bad ground. So I still have my test light connected to a battery positive. As soon as I touch the bracket or even the bolt where the bracket bolts to, this test light should turn on. And that pretty much verifies that our problem was a bad chassis ground. So here we go. I'm going to touch it. Our test light is on. I'm going to touch the bracket. It's good. So that pretty much verifies that our problem is a chassis ground problem that's not allowing this 12 volts to ground to chassis ground. So here we go. So one thing I could do to see if this horn works is to connect that connector back to the horn and use a test light and manually energize the relay and see if this horn honks. So I'm going to do that and show you guys real quick. So I'm currently back probing the light green with black, which is the control side of this relay, which is the ground side. I have my Tesla already connected to ground to the battery negative. So in other words, I'm going to bypass the horn switch by using the test light. I'm going to manually energize it by touching that pin there on the light green with black, and this horn should turn on. So here we go. So as soon as I touched it with the test light, we saw that the horn was honking. So that just verifies that the problem was a faulty chassis ground that was not grounding this 12 volts on the chassis frame. I'm going to go ahead and use the horn switch to see if it operates with the horn switch on the steering wheel. So there you go. This also confirms that our horn switch is good. It's able to provide the 12 volts to the horn switch. Alright guys, so so here's the options. I've already found 2 locations to perhaps put a ground wire on the brackets, on the bracket of the horn where it bolts to the frame, and run that ground wire to perhaps either to this location here where there's an option to actually thread a bolt, or there's another one down here which is right there, but I see that perhaps water runs through that location. It might end up being a bad location to put that ground, so I'll put it right here instead. So I'm gonna go ahead and create a ground wire, put it on, and then just confirm the fix. Alright guys, so I have already installed the ground wire, which I connected to the horn's bracket. I ran the ground wire all the way to the left side fender chassis. I'm going to confirm with you guys real quick with the test light connected to battery positive that, that we have a good solid ground now. I'm going to touch the fender's chassis ground here. So as I touch it, you see that our test light is actually turning on. So so that's a good solid ground. I'm going to touch the horn's bracket where I bolted the ground wire. So there you go. So it means that this horn now has a good ground, and this horn should work now as I hit the switch. I'm going to confirm with you guys real quick. I'm going to hit the switch, the horn switch real quick. So here we go. So that's a good working switch, also good working relay, and a good working horn. All it was missing, it was a ground. It was not able to provide a ground path for those 12 volts that were coming from the relay. Alright guys, so we have fixed this problem already by adding a ground wire to the horn circuit. Now the third symptom that this vehicle has is a low beam. Off camera, I've already did a visual inspection on both headlamps, on both low beams, and the problem is actually that both of the low beam headlamps, headlights bulbs are actually blown. If not, they're not really blown, but they're not making continuity no more. I'm not sure if the camera could pick it up, but the low beam filament, it looks kind of damaged already on both sides. I'm going to show you guys real quick that only the high beams work, but not the low beams. I'm going to first hit the switch for the low beams. That's a low beam right there. The only lights that turn on are your parking lights on both sides. There's no low beam operation here. I'm gonna hit the high beams real quick. So that's with the high beams. There's the indicator right there with the blue indicator. So there you go. That's the high beams. Also there shows the high beams turned on. So the fix for this is to pretty much replace these light bulbs for the headlamps for the low beam, and that should be the fix. Alright guys, so hopefully you guys enjoyed this troubleshooting, especially on the horn circuit. Hopefully you guys learned something from my troubleshooting steps. Alright guys, so this is Eli the OBD Tech. Subscribe if you like.